Junaid, better come up and plug yourself in. While you do that, I will wrap here and say Junaid is a math and data science PhD student at UW Seattle, graduating this June. Most of his day-to-day research focuses on AI interpretability, and computational number theory, and managing all the data regarding method in bench bank databases. Before this, he spent some time working on cryptography and algebraic geometry. He's currently looking for roles in the Seattle area, and after graduation, outside of work, he's usually hiking or watching soccer, cricket, and F1. Good.
Thank you. Am I audible? Yes. So this talk is on benchmarking database systems. It's a continuation of a project that I did as part of a database course at UW. It was taught by Dan, if you know. Okay, so but I worked a little bit more than the project, so this is more or less a fresh, or like I've added more stuff. Yeah, so the problem is the following. So we all want to, we all have so many questions that we want to answer. We are curious. So suppose you have a question that you need a data size that can fit in your laptop. Suppose say, 10 gigabytes. It's probably too big for Excel, and it's probably too small to spin up a Spark or So it's common in local data science workflows. For example, if you are into public transport, so the New York Taxi, they have a huge, I think, 17-year-old continuous data set, NYC yellow taxi. So I'm talking about these taxis. These operate all throughout NYC. The green ones are fairly newer. They are not allowed in, I think, Manhattan. So I suppose so this project I looked at 2024 data, and it has about 41 million rides. These are all Parquet files, so they are compressed in about 800 megs, but if you create a CSV, it would be about 6 gigs. Yes, this is map of New York, probably everyone knows. But the key area is this is Manhattan 1, and these are the 4 outer boroughs. Okay, so before we start, all of us will have to download that data set and then create a table if you are using Postgres, or even like SQLite. So just before you can ask questions, you have to create a table, and for DuckDB and Polars, they are native Parquet readers, so there is nothing need to be done. Whereas for Postgres, it will need at least 2000 seconds at least on my laptop, which is like a 5-year-old laptop. I also worked on an older desktop. So this is, I think, Haswell generation, which is, I think, 14-year-old. You can have the single core scores are roughly half of the Apple M1. I mean, these days DDR3 is kind of outdated, but if you are looking at RAM prices, probably it's not outdated. Anyway, so the memory bandwidth is roughly 6x lower. Anyway, so these are the two hardware that I'll put some. So the data set more or less looks like the following. So you have a vendor ID. This is basically how they are registered, how the payment happens, or how the driver is registered, and then you have a date, time, drop pickup, how many passengers, trip distance, some other flags. The key thing that's important is where the pickup happened and where the drop off happened and how did the people pay. So 1 is, I think, credit card, 2 is cash. And they also record tips. For some reason, whenever the payment is cash, the tip is by default 0, so maybe the drivers don't report. Anyways, yeah, so I couldn't analyze tips on cache. Yeah, there are other things that one could look at, like if there was some surcharge and so on. Okay, so straight away, if you download a data set, you want to see how more or less each column looks. So suppose you are looking at the fare column and you want to know roughly how much is a fare in New York. So as you can see, it's a heavy tail. So I think it's probably because either people go to airports mostly, maybe the public transport people who use airports, or the regular users, something about either like $15 or $70. And similarly for the trip distance, so these have some tails. So the reason why I'm saying these long tails are important because the query optimizer cannot more or less gauge these long tails as it will be clear. This is also the tip amount. So yeah, some people, I think this is due to the cache, but I think I have filtered it out. Okay, so this is only credit card. So yeah, you can, I don't know, you can judge or not judge. Okay, so now there are these 3 questions that one can ask, and I've selected them more or less for reasons. Maybe I can get into that since we have more time. So the first question is more or less along the lines of how do people move across boroughs? So let's go into that. Before that, these are the latest versions I could find, and I was using those. Okay, so the first question is, if someone wants to go from Manhattan to Queens, how many such trips were there? The reason I've picked up Manhattan and Queens is because it's fairly less percentage. So you can see this is roughly 1.1 million trips. The total number of trips are 42 million or 41 million. So it's something like 3%. Because it's 3%, what will happen is the query optimizer, so these are scarce, these are not fairly common. So when you estimate queries, there will be some either undercount or overcount. Okay, so this was the more or less a simple join. So you join the two and you compare when they are okay. And if you look at the explain analyze, it tells you what plan each one was using. So either it was a vectorized hash join or some push down. Whereas the problem with Pandas is it just tries to be very eager. It doesn't want to optimize at all. So because of that, Pandas is pretty slow. Postgres, we will come into why Postgres is good. So on a few of these, because these are analytical queries, Postgres by default is at a disadvantage. Yes.
Can you go back to the other slide?
Yes.
For like 10 seconds. That's super interesting. I was just trying to read it all. Do you want to describe what the queries do? So the queries.
Yes. Yeah. So I select. So I'm joining the pickup location. And drop off, and where is this?
Okay, so PU is the pickup location, DZ is the destination. You're joining off the trips table, and then this is how you're doing a source of Manhattan and a destination of Queens. And so specifically, like if you go back one more slide.
Yes.
This is doing the 34 million. Okay, no, this is Manhattan Queens. This is what you were saying. Your queries in the 2.2 or 1.1 box.
Yes. This box.
Yes, and this is super fascinating because this is the kind of thing that like screws up databases all the time. As you were saying, like the skew.
Yep.
Yeah. Okay. Thanks. And I'm kind of tracking with that now.
No, it's fine. Yeah. So yeah, the query optimizer, it basically, instead of looking at the whole data set, it looks at a subset and it tries to estimate how much and then decides what plan to use. And because these are rare events, I mean 1% you may say is not that rare, but I mean, yeah. So it may underestimate, overestimate, and so the plan may not be fully optimal. Okay, so here, I mean, yes, the analytical, so one takeaway is if you are using Pandas in a Python workflow, a quick fix is to use polars. You may get like twice a speed bump. They are fairly compatible. And if you are like using analytical queries, DuckDB is pretty good. I mean, I think DuckDB also has a Python API. So anyway, so the other question is similar, but now we are not looking at where the trips happen, but so this question, I mean, I will get into the motivation. So suppose the question is, when does you have a cache trip but longer than 10 miles? So this is kind of very rare. You can again imagine. People usually pay cash for short distance. If you are going to the airport or I don't know, 20 miles, probably you are going to pay with an electronic payment, right? So, or you can say these are anti-correlated events. So that's why, yeah. So these are also quite rare. But here, yeah. So only about 1%. So this was you just filter for credit, and yeah, there is no join more or less. And this is the Python. It's one of the most simple code I think one can write, right? You just look at the column, set it 2, and look at another column, make it bigger than 10. Yes. Question?
Do we know what distance is the break even between cache and credit?
Oh, that's fascinating. So you're asking at what distance? Yeah. No, I haven't looked at it, but that'll be great. Yeah. So basically, I think the question is, as you increase distance, the ratio of credit to cache should increase, right? At what distance does ratio of credit to cache is half, or yeah, or 1? So ratio will be 1. Yeah. Yeah, so again, a similar, more or less, so these analytical engines are pretty good, but Postgres is not too bad. It's a row optimized system, still it's performing pretty good, at least much better than SQLite. Okay, so finally the last question. So this is more or less a more deep question. So in the rush hour, would you want to take a cab or not? So it's kind of like that. So if you are in the yellow zone, which means Manhattan, probably not. The speed would be too low. I think you can walk at, I don't know, maybe 3 miles an hour. So maybe it's still fine. Whereas if you are in the outer boroughs, definitely you're like 20 times faster. Yeah. So this one needs a lot of steps. So first select the service zone, average out. So there could be some nulls, and this is the total time, make it into hour, like computing speed basically, and then when the pickup and drop, there is a join here, and so this is the rush hour filter between I think this is 5 p.m. and 7 p.m. and finally you order by, yeah. So in this case, you can see for some reason DuckDB doesn't like old machines. DuckDB loves newer hardware. Yeah, I don't have any other interesting pattern. If someone spots, that's also useful. Yes.
I hope it's okay if we ask questions in the middle instead of waiting for
Yes.
My other question was the example query that you had. Was
Yes.
that, were you able to use the same query across all of the databases, or is this just like the version from one of the databases and you had to write it slightly different for other ones?
So I think I wrote a different one for Pandas, but for DuckDB it was the same. And Polars has So Polars allows one to write either like a SQLized query or like a Pythonized. Um, yeah. By the way, the code is here. It's available for anyone to look at. It's yeah. I have a plug at the end, but you can look at it and suggest improvements or something.
Did you gauge memory consumption at all?
Sorry?
Did you gauge, say, memory consumption during the query?
Oh yes, I did. But I was very lazy. I'll tell you more about it. It's not very easy to track. Yes.
I was just going to say, so the reason why the difference in performance is so large for DuckDB is because different processor architectures have different vector intrinsic supports.
Mm-hmm.
So because it's a vectorized query engine, a lot of the newer operators won't be available.
Okay. Wow. Yeah. Yeah. If someone wants, okay. So you are saying maybe Apple has like parallelized some of these. I don't know.
Yeah. Every processor generation, there's like specs for x86
Yeah.
and ARM. They have different flags for vector intrinsic supports,
Yeah.
right? So like when you're compiling like native code like C or Rust,
Yeah.
you can flip those on.
Yeah. Cool.
Yeah, if it doesn't have those vector intrinsics, then it can't compile it as efficiently.
Yeah, one other takeaway is if you are using Pandas or Polars, you don't have to upgrade more or less. But even if you are compared, it's not too bad. Anyways, yeah, so this is the memory one. The reason why, so I think I had, so this is a server and I did not close a lot of applications. So I was being very lazy here, but for this one I was sure that only my terminal was running. So that's why this don't see the desktop slide. For the laptop one, yes, as you can see, Pandas consumes huge memory during setup, as well as yeah, more or less, Pandas and SQLite consume the most memory. But Postgres was pretty efficient. For example, the third query, it's the most challenging one, and it's on par with all of these like. Yeah, so DuckDB and Polars should win. It's their home ground, but Postgres is not too bad. So this was the more. Maybe I should zoom it. This is the last slide. Okay, I'll try to zoom it. So this is the variability slide where what I do is I change the constants in my queries. So instead of say 5 p.m. and 7 p.m., you change it to some random numbers. And you run the queries again and again, and you plot the times. So this is just to check, maybe it was not a fluke what I was observing. So these are I think I ran it on 2 tasks, a join and a filter. And yeah, this is horrible to read. But more or less, the key takeaway is Postgres is pretty stable. So this is Postgres. It doesn't care what I gave, it's the same performance. Whereas, yes.
How broad was the range of random numbers you were using? Was it like 1 to 10 or like 1 to a million?
So I did not run too many queries because it was taking too much time. It was only 20 queries, okay. And I don't think it was pretty broad.
Okay. So what's happening there is that you're hitting the query plan cache, right? Mm-hmm. So like the query planner is like parsing that query, and when you resubmit it, if it uses the same variables, it won't do any calculations. It will just go straight to reads. Mm. So you have to set like a GUC, like a statement variable for Postgres at the top to see whether or not your query is like in the query plan cache, or you can explicitly disable it.
Yeah, disable it and then test. Yeah. I should have been more clean with my. Yeah. Anyway, so SQLite, as you can see, is crazy variable. So don't believe any Twitter on SQLite. Whereas Polars and DuckDB are also pretty stable, but yeah, Postgres is crazy stable, maybe because of cache. Yeah. All right, so that's my last slide. Thanks for your time and thanks for the opportunity. All right.
More questions? How big was the row group on the Parquet files? Like sometimes you can adjust that and you might be able to get better performance on the old machine.
Sorry, on the
How
Parquet.
big was the row group?
The row group?
There's chunks of data in the Parquet files.
Okay, I did not look at, yeah, I should, yeah, I see what you're saying. So per case columnar, so you're saying how many chunks?
Yeah, it helps with out-of-memory processing, but I think DuckDB is roughly 100,000. But I think I think that I've seen things where they've adjusted the row groups and colors and stuff better. It might do better on the older machine.
Wow.
Different size charts.
So I think it's really interesting. That's sort of like an apples to oranges thing, right? You can't compare like columnar and row store databases.
Yes.
But one thing at the beginning is that if you're maybe a Python user here, when you're loading a huge amount of data into Postgres, especially if it's like temporary data, you don't want that to go through the write-ahead log, right? So you would want to create a temporary unlogged table, batch load all of your data, and then restore the wall if you want transactionality. Because it doesn't really matter when you're loading that data in, right? Like your laptop's not going to turn off, or if it does, you just redo it. So if you ever want to load like a huge amount of data into Postgres without taking forever, create an unlogged table to turn off the wall, and